Okay, gang, this should be the last video for this week. Okay, so we took care of these guys. Okay, now we're going to be taking a look at stuff like this and stuff like this. Notice that this guy and these three, they're all differences of squares. Okay, so these are actually a little bit easier, okay, than dealing with these guys because you're not going to have to complete the square on them. Okay, so why don't we start with this guy? And again, notice that all of these guys are parabolas that either open up, okay, or down. Okay, so all of them are going to pass the horizontal line test. Okay, so once again, we spent I think every problem the last 2 days we worked on talking about the domains and ranges of the original function and the inverse, and we've done enough of that, so I'm not going to continue to do that. Okay, so right here, okay, so get it out of function notation, so we get y equals 25 minus 4x squared, and then switch the x's and y's, so we get x equals 25 minus 4y squared. All right, now I'm going to have to solve for y. And as it stands right here, that has a negative coefficient here. And I don't want to make a sign mistake down the road when I divide by a negative number. So what I'm going to do is I'm going to move this guy over to change it to positive. So I'll have the y on the left, which means everything else has to go on the right. Okay, so I get a positive 4y squared equals 25 minus x, like that. Divide both sides by 4, so I get y squared equals 25 minus x over 4. And this is a reduced fraction, so all I got to do is take the square roots. Okay, and obviously this is a positive number, so I take the 2 square roots. Okay, so I get y equals plus or minus, okay, and I would apply the quotient rule, 25 minus x over square root of 4. And again, I luck out because that denominator is a perfect square, so it rationalizes itself. So I get y equals plus or minus the square root of 25 minus x all over 2. Okay, so go back to function notation, and this is an inverse. Okay, so again, I say g inverse of x equals plus or minus the square root of 25 minus x all over 2. And if I wanted to split that up, okay, I could say g inverse of x, okay, is equal to these two functions, a positive 25 minus x all over 2, and a negative square root of 25 minus x all over 2, okay? And it's just a matter of how you want to represent your answer. Both of those are 100% correct. Okay, so you can see a lot easier. We don't have to complete the square on these guys. So these guys are pretty easy. Okay, so we got 3 more of these guys to do. Okay, so we start here. Okay, once again, get rid of the f of x and go to y equals 9x squared minus 100. Switch the x's and y's, so we get x equals 9y squared minus 100. Okay, isolate the term with y, so I get x plus 100 equals 9y squared. Divide by 9. So I end up with y squared equals x plus 100 divided by 9, and then we take the square roots. And obviously I have to take both of them, okay? X plus 100 over 9 has to be a positive number, okay? So it has 2 square roots. So I get y equals plus or minus. Once again, the denominator is a perfect square, so use the quotient rule to rationalize it. Square root of x plus 100 over the square root of 9. So I end up with y equals plus or minus square root of x plus 100 all over 3. Okay, and then we go back to function notation. Let's see, it's f, so this is f inverse. Okay, so I can say f inverse of x equals plus or minus square root of x plus 100 all over 3. Or if you want to split things up, f inverse of x equals, okay, I'd have positive square root of x plus 100 over 3, or I'd have negative square root of x plus 100 all over 3. Okay, so again, either or, it's up to you. Okay, so we're good there. Let's go down to this next one down. Okay, so we get y equals 4 minus 81x squared. Switch the x's and y's, so we get x equals 4 minus 81y squared. All right, so this guy is like the first one we did, where notice the y has a negative coefficient. Okay, so rather than having to worry about dividing by a negative number later on, I am going to just manipulate this, okay, so that it doesn't have a negative coefficient. So if I take this guy and move it over to the left, it becomes positive, which means this guy has to come over to the right. Okay, so I get 81y squared equals 4 minus x, and then divide by 81. Okay, so y squared equals 4 minus x all over 81, and then we take the square roots, and again, okay, this has to be a positive number. Okay, so it has 2 square roots, so we get y equals plus or minus. And again, the denominator is a perfect square, so go ahead and use the quotient rule to rationalize it. Okay, so I get square root of 4 minus x over the square root of 81, which gives me y equals plus or minus the square root of 4 minus x all over 9. Okay, and then we just go back to function notation. And obviously this is an inverse function, so it's going to be f inverse, so f inverse of x equals plus or minus square root of 4 minus x all over 9. And you could leave it that way, or once again, just like all the other ones, you can split it up into 2 separate functions. It's entirely up to you. So positive square root of 4 minus x over 9, and the negative square root of 4 minus x all over 9. Entirely up to you, okay? So we got one more to do, okay? And that will be our last problem for the video. Okay, so notice that this guy is just like the last one, as well as like the very first one we did, where the coefficient for x squared is negative. So at some point I'm going to manipulate it so I don't have to deal with dividing by a negative number. Okay, so let's see, get it out of function notation. 121 minus 25x squared. Okay, switch the x's and y's, so we get x equals 121 minus 25y squared. I want to get rid of that negative coefficient, so if I bring it over to the left, it'll become positive, which means this guy has to go away. Okay, so we get 25y squared equals 121 minus x. Divide by 25, so we get y squared equals 121 minus x all over 25. Take the square roots, and obviously this has to be a positive number, so I got 2 square roots. And once again, apply the quotient rule. So we take the square root of the numerator over the square root of the denominator, and that rationalizes it for us because the denominator is a perfect square. So we get y equals plus or minus the square root of 121 minus x all over 5. And then we go back to function notation, and this is an inverse function. The original function is f, so this is f inverse of x, and we're going to get positive or negative square root of 121 minus x all over 5, okay? And if you want to split it up, just like we did in the other ones, okay, you can do that. It's up to you. Doesn't make any difference to me. I couldn't care less. So positive square root of 121 minus x over 5, and a negative square root of 121 minus x over 5. Okay, once again, either form is 100% correct. It's just a matter of what form you want to go with. Okay, so that will wrap it up for videos this week. Okay, hopefully you guys have already started working on the 2 homework assignments. Okay, you got to get those guys turned in, and the quiz, which of course is due like it always is next Monday.